Hey everyone, welcome to Compound Events. This is going to be concept number 4. We're going to be talking about dependent events today. Okay, concept 3 was independent events. So, dependent events, when the outcome of one event does affect the outcome of the other event. Okay, so we have an effect here. So, the probability of A and B is going to be the probability of A times the probability of B after A occurs there. So the probability of A times the probability of B after A occurs. So this is going to be something without replacement. So we're going to use the same examples we did, but not replacing. So it's our crayon example: 8 red crayons, 14 purple, 6 yellow, and 4 green crayons. We're gonna select a crayon. We're gonna not replace it, and then we're gonna select another one. And now we got to find the new probabilities here. Okay, so the probability of yellow, then a red. Well, the probability of yellow is going to be 6 yellow out of 32 crayons. If you add all those crayons up, that's the sample space. And we're going to multiply that by our new denominator, because now we're going to look for a red. Well, if you take a crayon out and don't replace it, there is only 31 left, so that red number changes. And then we know that there's still 8 red crayons in there, so we put 8 here. And that simplifies into being 3 over 62. You can simplify ahead of time or at the end, it doesn't matter either way. So our second example, let's say all the crayons are back now. We're going to draw a purple. What's the probability of selecting a purple, then a green? So the probability of purple now are 14 purple crayons out of 32, and we're going to multiply that to the probability of drawing a green. Okay, so the green, there's only 31 left, but the first one was purple, so we still have 4 green crayons. So that goes here. And when you simplify this out, this is 7 out of 124. So that's the probability of the likelihood you're going to draw a purple first, then a green. Now, here's this one's different. On the bottom, so the probability of 2 reds. Well, there are 8 red crayons. So my first probability, the probability of drawing a red crayon is 8 out of 32 times. Now, both of these are going to switch. Both are going to switch because now if there's one red crayon without being replaced, there's only 7 left, and there's only 31 crayons left. So you multiply that out, and you end up with 7 out of 124. Same likelihood as purple, then a green. Okay, in our last example on this page, the probability of 2 greens, well, the 2 greens, green is 4 out of 32. Again, you can reduce if you want to. Times, now there's only 3 green crayons out of 31. Okay, and that reduces to 3 out of 248. Okay, so that's just a crayon example without replacement. I've got a couple more to show you from your notes. Okay, so next example, a card is drawn from a standard deck. That means there's 52 cards, and it's not replaced. And another is drawn. What is the probability of choosing a heart, then a spade? Okay, so, well, choosing a heart, there are 13 hearts out of 52 cards. We're going to multiply that now by drawing a spade. Okay, so that is going to be 13 because we haven't drawn any spades yet because it was all hearts the first time. But the bottom number is now 51 because we took out one card and we didn't replace it. So 13 over 52, that's the probability of drawing a heart. Then if we need to draw a second card, we want that to be a spade. There are still 13 spades left, and there's only 51 cards though. So our total ends up being the probability, not total, is 13 out of 204. That's the probability you're going to draw a heart, then a spade. Last example, Jack has 4 Snickers bars and 8 Mars bars. He must be from Europe because you can't get Mars bars here in the States unless you know somebody. He randomly chose a piece of candy, ate it, then chose another. What's the probability that both candy bars were Snickers? Ooh, I love Snickers. So we have 4 Snickers and 8 Mars bars. So that means there are a total of 12 candy bars. And the first one we want to draw is a Snickers. There are 4 Snickers bars. I don't know why I put red there. We're going to need red here in a minute. Times, well, without replacing it, you ate it, it's gone. There's only 11 now to choose from on the second one because we're drawing another bar. And we want that one to be Snickers as well. So there's only 3 here. Okay, so when you multiply those together, it actually ends up being 1 over 11. And you can probably see go 1 here, 4 here, and that becomes 1 and 1. So you simplify pretty quick. All right, so that is a compound events with two simple events when the events are dependent on one another. So if you have any questions or comments, let me know, and we'll see you next time.